Hello everybody, this is Ed. Today we're going to go through a LeetCode challenge, your favorite spiral matrix problem. So, the instructions are as follows. Given a matrix of m by n elements, return all elements of the matrix in spiral order. Let's illustrate this problem on our interactive whiteboard / paintbrush application. One thing I miss about Windows computers is that their paint application is like 10 times better. Hopefully they make something similar for the Mac. Anyway, this is the matrix in example 1 through 9, with 3 rows and 3 columns. Alright, so what does it mean, spiral? Well, simply means starting from row 0 and column 0. Apologies, this should be column. This is row, so rows start from the very top at 0. Columns start from the very left at 0. So starting from 0, 0, right here, we're going to go in a clockwise direction until we reach the very center of the matrix, or close to the center. So this is what our path would look like. There we go. And as you can see on LeetCode, this path and the order in which we cross the numbers matches the output. 1, 2, 3, 6, 9, 8, 7, 4, 5. Okay. Yep, and that's how you do. Just kidding. I'm actually going to show you how to set up your for loops in order to traverse them correctly, because it took me a little while to get all my boundaries straight. So I think a good analogy for solving this would be an origami box within a box, which I have provided here. So why provide this visualization? Because I want you to imagine this matrix as a series of boxes within each other. The box on the outside is the layer of numbers on the outside, right? So in this case, the outer layer would be these 8 numbers, and the inner layer would be this number, right? You could imagine we could make the boxes rectangular so that there are more rows and columns, or more columns and rows. The same concept applies. Okay, so now that you've got that picture in your head, let's actually show you the bounds right here. So let's get rid of these. Oh man. So another thing about Paintbrush is that it can't remember anything longer than 10 steps ago, so I gotta erase these manually. Okay, so now that we have our original matrix here, almost, okay, so how do we traverse a layer? So remember, we've defined a layer as a box, right? So let's say all the numbers immediately inside, right next to the layer, are included, right? So this layer would include 1, 2, 3. Actually, let's make this a little more intuitive. Okay, so anything the yellow line crosses is part of this layer. So each layer is going to be rectangular in shape, right? And we know a rectangle is going to have 4 sides, right? So there's going to be a top, bottom. Actually, let's go in clockwise order, right? Because that's how we want to add the numbers to our array. Top right, bottom left. Okay, so you might imagine, what do we need to traverse each of these layers? What are we going to use? Well, that's called a for loop. One of the most, the first things you learn in programming is like, they teach it in intro courses, it's the for loop. And basically, yeah, that's all you really need to know to solve this problem. Just for loops, nothing fancy. You just had to be careful with how you set up the problem. So right now I am circling the numbers that are going to be included in our for loop. Now, there can be different ways in which you set up your for loop, and you'll still be able to solve the problem. What I mean is, like this blue, you can do it up to here, right? And then you can have your right column include these three on the right. I'm just doing it the way I did it, and you guys can experiment the way you want. So our right side will include the numbers just below the top layer, or I should say the top side, until the very bottom. And the bottom will include the numbers just to the left of the right layer. And the left layer includes the numbers that have not been included by all the other layers. So you can see after we go through our four for loops. So I'm going to remind you that we are using a for loop for each side to traverse the numbers in each side. We complete a layer. What do we do after we complete a layer? Well, we want to move on to the next layer, the inner layer, right? So we want to adjust our boundaries one by one in the inner direction. Okay, so we have four sides, which means we're going to have four boundaries. We're going to have, so this is going to be our row. So this is row, row, and this is column, column, right? So the row on the top, so this is our top layer. That's going to be our upper boundary. And we're going to initialize this to 0. Because we're going to always start at 0, row 0, okay? Apologies, let me make this a little clearer. Okay, we're going to start at row 0. How about the bottom boundary, the bottom row? Well, that's going to be the row of our bottom side, and that is going to be initialized to the length of the matrix minus 1. So the length of this matrix is a 3 by 3 matrix, so 3 minus 1 is 2. Alright, and our right side is going to define our right boundary, and our columns are arranged from left to right. So the right column is going to be initialized to the number of columns minus 1. And our left is also going to be initialized to 0. Okay, So we have got all our boundaries set up, which is a major piece of solving this problem. Now I'm just gonna make this a little easier to understand by rearranging these boundaries. I'm gonna put this next to this and this next to this. Okay, so now you get the top and the bottom limits for the rows, and the left and the right limits for the columns. So we want 4 for loops in our first for loop, and that is the top for loop, right? We want to go from row, so let's call this the top R, and let's call this the bottom R. R means row, and let's call this actually let's use low instead. So low R and high R, and low column and high column. So in our top for loop, we want to go from low column, right? So we are doing this one right here, traversing this side right here. So we keep the row the same, which is the low R. But we want to go from the low column to the high column. So let's say from low column to high column at low R. Apologies. So for our bottom for loop, okay, take a minute to think about what our for loop would look like. Okay, so we want to start from, so we are going from the top row to the bottom row, but we don't include the top row because that's already been included in our top side, right? So we want to go from low R plus 1 to high R. And the column is going to stay the same in this case, right? It's not going to change for this side. So we're going to keep this constant at high C. All right, 2 more sides left. So, oh, looks like I jumped the gun. This should actually be right. Okay, so let's do bottom now. We want to go from, so we're doing the bottom, which is this side. So we are traversing the columns in this case. And if you look at this picture right here, we see that we do not include the rightmost column because it's already been included in the right side. So we can say from high R, high C minus 1 to low C. And we're going to do this at the higher row, right? The row is not going to change. Okay, one more side left, the left side. So the left side is going to be similar to the right side, except instead of traversing the rows, at the higher column, this side. So remember, higher column is right here. We want to do it at the low column. So this should be pretty simple to write. I'm just going to copy this, try it here, and let's write at low column. Okay, so this basically takes care of one layer of our matrix. So this takes care of one layer. Oops. So we want to continue doing this. So we need to adjust our boundaries after we finish a layer. So we want to adjust these boundaries inside, right? So that means we need to adjust the boundaries that we've defined earlier. By 1. So we want to adjust our top boundary by 1. Our bottom boundary is going to be decreased by 1 because decreasing the row will bring it inside in this direction. Okay, our left column should be increased by 1 to bring it to the right, and our right column should be decreased by 1 to the left. So as a result, we get 1 as our top row now, 1 as our bottom row, 1 as our right boundary, and 1 as our left boundary. So we do not want to stop unwrapping these layers when the top boundary equals the bottom boundary and the left boundary equals the right boundary. In this case, we want to include this number, right? So our condition for whether or not to continue traversing the inner layers should be as follows. We should check while. Okay, t, remember that's our top boundary, minus bottom is greater than or equal to 0, and right minus left is greater than or equal to 0. We're going to keep exploring the layers and adjusting our bounds by 1 to explore the inner layers, right? Okay, yeah, so that is basically how this problem works. If you want to see, this is the code that I wrote up for this problem, problem, I mean. You can see the for loops that I've included. Now there's a wrinkle in here that I haven't explained. It's this if statement right here that kind of is a condition for entering the bottom and the left side. Now this basically says that checks if we enter a situation in which our high column equals our low column or our high row equals our left row. In that case, there's just going to be a single row or column of numbers which we want to explore. If we didn't have this if statement, it would actually traverse the same numbers twice. So let's say it would treat the up side and bottom side the same. So it would think they're two different sides, but it's actually the same side. So we don't want to do that. So we want to check whether there is actually more than one row and more than one column before we traverse the numbers in the square or rectangle, right? Actually, let me just go through that example real quick. So okay, I can just copy this here. Okay, so you could imagine we do this, we're gonna traverse one layer of this. We end up here. So our next layer is going to be this stuff right here, right? Now you notice this is not a square or rectangle, so it doesn't have 4 sides. It only has 2 sides. So that means we only want to traverse 2 sides, right? So in this case, we're only going to traverse the top and the right side. The top side is going to include all of these. The right side doesn't have a right side, right? And this if statement prevents us from including the same numbers in the bottom side. So that's basically what it's there for. Okay, anyway, hope you learned something. Have fun doing this problem. And thanks. Merry Christmas. Bye.